Okay, this is a demonstration of Tekla TEDs. We're using this in CTR 07103 and also in 104. We'll change screen. This is a tutorial that my colleague Wojtek will have given yourselves out to do. We're going to try and replicate that in Tekla TEDs, but in a very short period of time. Now, we'll go here, we'll go home, we'll go new. I'll bring that to the other screen. We'll go analysis, we'll go 2D analysis, and we'll go 2D analysis, and there we are. Once it loads up, move it to this screen. I'm going to start off by putting nodal points in. We'll always start off with 0, 0. And then we'll go along the x-axis, and it'll be 2 meters up 0, and then it'll be 3 meters up 0, and then it'll be 8 meters up 0, and then 10 meters up 0. I'm going to hold nodal point number 3. I'll fix that in horizontal and vertical, and I'm going to hold nodal point number 4. I'm going to fix that in just the vertical. That will be the z-axis. And we can see my icons have changed. My first icon here for node 3 is a small triangle, and for node 4 is a triangle with wheels on it to indicate that it's got freedom of movement horizontally. I'll go to materials. I'm just going to add a material, and then I will just pick something at random. 10 meter. I'll do some steel. Steel to Unicode 3. Then I'll go sections. I'll select section, steel, Unicode, press OK, and then get a little drop down menu. I'll pick a steel member that I know quite well, a universal beam, is it 10 meter span. I'll do a 305, and I'll do a 54 kg per linear meter. Kilograms per linear meter. That's a 305, 165 by 54. That's not overly relevant, but we want something that can actually do that sort of span for it to work. Press OK, and we'll go elements. I'll go from node 1 to node 2, node 2 to node 3, node 3 to node 4, node 4 to node 5. Excellent. And everything is fully fixed, so it's one member. We'll go design, I'll press edit, and I'll just say the start element 1, end element 4, and we can see that node 3 and node 4 are already ticked as being held, or supported, sorry, so that's absolutely fine. We'll press OK there. I'll give that a name, beam. Then we'll go loadings. This gets interesting. We're going to take self-weight off, and I would imagine that my colleague Wojtek has put everything as a permanent load. That's fine. We shall go element loads first of all, and just remind you again what we're trying to replicate. We're trying to replicate this. So we'll go element number 1, permanent, and that happens to be 12 kilonewtons per linear meter load. And element 2 will be the same. And element 3 would also be the same. Perfect. And we also have some point loads as well. We've got a point load at node 2 and a point load at the very last. So let's see what these point loads are. So we'll go here, we'll go nodal loads, we'll go node 2, We'll leave it as permanent for just now, and it's a vertical direction, so it's a z-axis, and that'll be 10 kilonewtons. We can see that it's been added on there, and then we've got one more, and that would be node 5. Node 5, and this is only a 4 kilonewton load. For load combinations, I think for just now, I'm not going to bother with load combinations just now. We'll maybe use this in second year. We'll go to results, we'll go to permanent, and we'll have a look at, for example, there's your moment distribution curve. We've got your shear, we've got deflection. We've got a lot of deflection at this end, but not very much at this end. You can also have your results. We've got the nodal reactions, so node 2 has got a vertical reaction. Sorry. Reactions here, sorry, node 3 has a reaction of 87.2, and node 4 has only got a 22.8 kilonewton reaction. We can have a look at the elements, and we can see element number 2's got various actions happening on it. We can also more sensibly look at the full member design. This is analysing the whole object now, and it's giving you the largest moment and the position of that moment and the minimum moment and its position as well. The shear maximum, shear minimum, deflection maximum 12.19, and its position and the minimum and position as well. And then for output, you can actually decide what sort of output you would like. We have loadings, tables. I'll add something else in, deflections, and we'll press OK. And it'll give you a full breakdown of what it is you've got. And if you want to recalculate this, you can right click, calculate, you go back into the menus, and you can change things or the loadings as you see fit. Right, I hope that helps, and any questions, do give your lecturers the nod. They'll be able to answer any questions that you have. Thank you.